Good afternoon, dear friends. Today we will be looking for the planning tools. As I said in the previous lecture, there are so many tools that are used in the planning and they act as tools to get the network done and also to show the progress and also to cover all the 4 stages of project like project planning, project scheduling, project monitoring and project controlling. So these are the 4 stages that will be covered by the planning tools. One of the most important planning tool what we have seen is the CPM in one of the classes, and we have taken a numerical problem and we have explained how CPM works. This is one of the most important tool which many of the planners or many of the construction companies they use. The most important this is depending upon, or you can say all the planning tools are depending on WBS, as we have told that it is work breakdown structure. So work breakdown structure is the first step of any planning network or any planning method. So work breakdown structure, once it has been done, depending upon a building, when superstructure and substructure is delineated, then what are the activities that are involved in that requires to be given a time schedule. As we have seen, we allocated timings for each and every activity or each and every step of WBS. We need to estimate some time. Now these time estimates are 2 types. One is one time estimate and other one is 3 times estimate. 3 times. So here we have only TE, the most expected completion time. Here we have TO, TM and TP. These are the 3 time estimates. When we take one time estimate, it is taken to be the most expected or likely time for completion of one activity of the WBS or one activity in the CPM. Now 3 time estimates will involve T0, TM and TP. This is optimistic time, this is most likely time, this is pessimistic time. So once we go to this one, then we need to know what are they. First one I will take it as the TO. This is called to be the optimistic time, when everything goes on well. I mean, as you plan, it goes. There is nothing, no hindrance and no hurdle for any of the activities to be completed, as we have seen. So optimistic time is the shortest possible time. This is the shortest possible time in which an activity can be completed. This we call it as optimistic time because everything goes according to your plan. Nothing goes again, not even 1% probability is there where the activity is being delayed. All the activities and all the complete activities in the network will go according to the plan. Everything goes on well, so everything is positive, everything is optimistic. That is why it is called to be the shortest time that an activity can take to get it completed or to get it accomplished. Now what is TM? TM is the most likely time. I will come back to TM after TP. TP is called to be the pessimistic time. Now this pessimistic time means everything goes not according to your plan. Everything goes in the worst way. That means every activity will be delayed and every hurdle comes. For example, rainfall will come, flooding may occur, and there may be so many climatic things that will happen, floodings and then wind, for example. All the delays, even there will be some strikes of the labor. So what material is not available, money is not available, machinery is not available. So that means TP means it is a pessimistic time when everything goes not according to your plan. Everything goes in a wrong way. Nothing works out. That is the pessimistic time. So this is called to be the longest time for an activity to get it accomplished. That means this is the shortest time is optimistic when everything goes on well. This is pessimistic time when everything goes on wrong. Nothing goes according to your plan, according to the engineer's plan. In between these two, there is a average timing. This is called average and Tm is given to be as most likely time. That means it is the time that is there in the mind of the engineer, where he thinks, suppose if the shortest time required is 3 days, longest time required is 8 days, average time may be in between these two. That means average time means this is the most likely time that is available or that is embedded in the mind of the engineer or the planning engineer. So he will be having an idea, okay, this activity can be completed in 5 days or maximum maybe 4 days or 3 days. 3 days is the shortest, so it will be 5 days for example. So probably this 5 can be taken as most likely time. This 5 days is it is there in the mind of the engineer, where he thinks, okay, this activity will take this much time based on his experience, based on his calculation and based on his workout. So that means the most likely time always works most of the time in a planning network tool. Sometimes it may also go wrong because it is also associated with certain probability. If you take T naught, it is associated with probability. What is the probability here? We don't know. Maybe 10% to 20% possible, maybe. Where optimistic time, the activity takes only 3 days. What is pessimistic time? Again, it can be 10 to 20% or 30%, you can say, depending upon the nature of the work and depending upon the nature of the project. So pessimistic time, if you can 10 to 20% if you take, this is also shortest possible time, it is 10 to 20%, sometimes happens, sometimes doesn't. So average time can be in between 40 to 60, approximately I am giving a figure so that you can understand in a better way. That means the most likely time can be within a range of 40 to 60% of probability of completion. So why I am telling this? Because later with these 3 time estimates, probability is also associated. The probability of completion of a particular activity that we have to calculate. In one time estimate, when all these 3 timings are used in a formula where TE can be calculated using these 3. So it can be, this TE, the most, this is the early time or expected time, we can call it as an expected time. So TE is called to be the most expected time. This is not most likely, this is expected, TE. So this TE depends on T naught, TM, TP. So using these 3 time estimates, using a formula T naught plus, this will be equal to T naught plus 4 Tm plus Tp divided by 6. If you do this, you get the Te. So that means using T naught, using Tm, using Tp divided by 6, you get this formula. You get this time estimate. This is the exact time estimate which we have used in our CPM project. In the numerical problem, we have assumed activity A taking as 5 days earlier. So this 5 days is nothing but this. It has come from this. So what I mean to say is TE is the expected time now. Why is the most sure expected time? Why? Because it is depending on T naught, it is considering T naught, it is considering Tm, and it is also considering Tp. That is the reason why exactly this is taken as these 5 days, which we have used in our CPM network. So this way we try to calculate the timings, and this 5 days again, as we have seen in that, it can be critical or it can be non-critical. If it happens to be critical, definitely it will take 5 days, that is the maximum time. But we cannot say this maximum time has taken as pessimistic time, it is not same. So like that, we have to take a network and we have to assume the timings based on this formula, and this is the T. So this is the most likely, expected time, not most likely, it is an expected time, definite. So that will be considered in a network system. Now in this network system, when we try to use first, suppose you are taken the WBS and there may be 3 activities, like for example, this is your foundation, this is your completion of your substructure, this is your completion of superstructure. So I am taking into 3 different aspects, 3 different activities, major activities. Of course, they have so many major, for example, foundation itself or substructure is taken, substructure. This itself has footing, then itself have concreting, then curing, then filling back of the soil. So this itself, the substructure itself consists of so many sub activities, as I already told. So this can be divided. Suppose footing will take 2 weeks, you divide like this. It is total timing. If I am assume as A and taking 5 days, it can be taken as 2 days. Concreting can be taken as 1 day. Curing will be taken as maybe 1 day, and 1 day filling back. So that means one particular activity that is under consideration, substructure, has how many parts now? 1, 2, 3, 4. 1, 2, 3, 4. So 2, 1, 1, 1. That means I am trying to divide this activity, which is shown as an arrow going from left to right, into different sub activities that have been given, that have been a part of the completion of this work. So if you go on writing like this for a big project, which is a construction project, there are hundreds of activities involved in that, and also sub activities. So on a network diagram, if you consider CPM, we cannot go on dividing on the network like this. We cannot go on dividing the activities in this manner. So what we have to do, we have to consider this as a block. You can call it as a bar. One bar I am taking, one rectangular bar. In this you can put 2 days, 1 day, 1 day, and 1 day. So that means I am taking 2 days here, 1 day here, 1 day here, 1 day here. This particular activity, I am trying to divide that into different blocks. So one bar I am drawing, this one bar will be one activity, and this will be considered a 1, 2, 3, 4 sub activities. What I am trying to do, because it is very difficult to draw on the arrow the different timings depending upon the sub activities, we cannot divide this whole network diagram into different activities. Then it will become a very cumbersome, and the engineers cannot follow. That is the reason why, in order to make it simple, we are trying to draw a bar, and in this bar I am trying to divide based on the sub activities. So 2 days footing is taking, 1 day concreting is taking, 1 day curing is taking, 1 day filling is taking. So this bar can be divided into any number of activities, sub activities. For example, footing itself will be iron, that is reinforcement, then scaffolding, or we call it as a farm work. This has 2 activities, major activities. One is the reinforcement, that is iron. The second one is the farm work. So these 2 also can be again further divided in this if you want. Maybe 1 day it will take. So if you are able to follow this, I will divide it into one day and 1 day, but this will combinedly take 2 days. So that means if you draw in a bar, it will become easy for us to divide as many number of sub activities as possible, and as many number of sub activities we want to include in that, we can include. So it becomes a very easy diagram. And also when it comes to this one and this one, the people on the site, that is site engineer or the labor or whomsoever it is, they will not be able to follow this, but they will be able to follow this very easily. So that is the reason why the first an initial network tool is called to be a bar chart, a diagram called as bar chart diagram. Why it is coming, as I told already, bar chart is coming for this purpose. There are so many reasons and so many advantages. So if when you go on drawing like this, then it becomes a bar chart. So it will be drawn on a x-axis and y-axis. Y-axis you can put as an activity, x-axis I can put as a time, and you start doing. See, activity 1, draw the bar. This is 1. Activity 2, draw another bar. When it will start in this one, where are they? Here. Substructure, then you can put as a slab. So slab will occur only when substructure is complete. So I can draw this, activity 2. Activity 3 is finishing, for example. When this finishing will start, when maybe a part of the work is over and then finishing will take. So when you extend this x-axis, this one last stage, last drawn when a vertical line is drawn, that will give you the TPT. So this is TPT. As we have seen, total project time, it will come there. All the activities will be listed here and the bars will be given. And why I have drawn this bar starting from here and this bar ending here and this bar starting before this completion of 2, depending upon the interdependencies and also relationships between the activities. So that means once the superstructure is completed, then only we can go for the slab, and then only after the slab is been completed, in between only when slab cleaning is going on, you can start finishing. So this is how we can arrange. So this one also will tell you the interdependencies of the activities in between them. So this diagram will clearly, of course, all these sub activities can be easily marked on that. On a time frame, it can be easily marked. So what I mean to say is a bar chart will become the easiest tool to follow by all the engineers, and that is the reason before we do any network tool or any CPM network, we need to make a bar chart of all the project. Complete project has to be represented in a bar chart. This you will easily get in one of the projects that is called to be the Primavera software. It will give you bar charts, or it can be taken from MS project. There are 2 softwares that are available even in Hyderabad. You can try to take the help of this, either Primavera or MS project. All these 2 will first give you the bar chart. In bar chart, all the interdependencies and the time frames, everything are very clearly mentioned. And it also helps in one last aspect. What I mean to say is the monitoring process. Suppose you go on the 10th day of the project, then you draw a line like this. Whatever on the left side, it has to be completed. Whatever on the right side, it is not completed. All these activities are not completed. That means when you go to the site, on this bar chart, you can just draw a line on the day you went, on the day the project has started. This line will give you the controlling line. That means it will clearly says what is on the left, what is on the right. Whether activities are still there or activities are still to be completed, or all the activities are done, or activities, there are 3 types. Are they on schedule, are they behind the schedule, are they ahead of schedule. So this is what exactly the bar chart will give. This is the most important beauty of the bar chart. So I hope the controlling how it is doing and how it can be done even using these 2 softwares or directly manually, I will be explaining in the next lecture. Okay, thank you very much, and circulate this to all the students, and if you have any doubts, you can directly DM me. Thank you.